Hello world, welcome back. Long overdue for an update for y'all. I've been working on my skull face. It's gonna get finished very, very soon. And I want to explain the electronics that are going inside of it. It took me a while to figure this out because I am pretty much self-taught. And I do a lot of things the wrong way. So I want to help you out in explaining how this is exactly going to work. It looks very messy on the table, but it's actually very quite simple, and I'll show you the drawing. All right, so this is basically the schematic. I'm going to show you a basic drawing. You don't need any sort of special programs in the computer. That stuff comes later. If you're experienced and advanced, that stuff's great. I just like pen and paper, and I like to do things really quick. I like to draw things as I think of it. And so I just, for a long time, I don't know, for some reason I just couldn't get this done. It's not a difficult build, it's just, I don't know, mentally I just couldn't do it. So I finally had an epiphany the other day that I had this voltage regulator chip lying around, and that's what I needed to make this build successful. I didn't want to use more than one battery pack. So my solution was to have, I can have 3.5 volts going into the chip. That's pretty weak. The chip can deal with a maximum of about, like 4.8 volts. You don't really want to go over 6 volts. That's when the chip might fry and it's just too much for the chip. So I got 3.5 volts times 2, so that's 7 volts. And our servo needs about, if you look at the data sheet, I'm using the SG90, the Tower Pro SG90 micro servo, and those need 4 to 6 volts. So I say about 5 volts. I'm going to get away with anything between, 4.5 and probably 8 volts. The higher the voltage, the more likely it's going to screw up. So you don't really want that. So I'm going to stick to around 4.5 and higher. And you notice it's coming out around 4.8, 4.9 volts. So I have all of that raw power right here. And then I have my battery hooked up in series. So it means one after the other. So I have a plus here, and then I have a minus here, and I hook the minus to the next plus. And then basically I have the positive coming out this way and the negative coming out that way. The switch that I showed you is going in the head. That's only connected to the positive line. Don't get confused. I used to get confused that the positive and the negative have to be connected to the switch, but that's not, you don't need to do that. That's not for what we're doing here. All you need to do is break the connection for one of them. You could have it on the ground side or the positive side, it doesn't matter. You just got to put the switch on one of those lines and then solder it up so that it goes into the switch and then it goes out of the switch. It just keeps continuing, and when you turn on the switch, it just bridges the gap. That's all it's doing, really. It's the same as a button, same as a push button. It's the same concept. So I am tapping, like I said, I'm tapping into this raw 7 volts of power to my servo. I have my servo connected to my pin, my PWM pin, where the signal's coming out that you saw in my last videos. And then after that, after I'm tapping into that raw power, I'm going to boost it down. I'm going to regulate it to about 4.8 volts, which is about the maximum recommended voltage for the Atmega 328P chip. And then I just have LEDs that I'm connected to the same line. Actually, this is not accurate. This is just my concept. I thought I had programmed them to come out of pins, and I realized, no, I'm going to use a potentiometer to control the brightness. So actually, the potentiometer is taking the plus and the minus, the positive, negative voltage, if you want to say, the red and black wires, over to the side, and it's acting as a middleman in between the power source here and the LEDs, basically. So that's what that is right there. It looks complicated, but it's actually just this. It's just the wires are really tall, and they get, people make those videos and they're perfect and stuff, I just want to show you my creative process, and don't get caught up in trying to make, you know, perfect things, sketch it out like this and get good at understanding the sketch. You don't have to draw it in schematic form, you know. You don't have to be one of those guys if you don't want to. I just like to draw it the way I understand it, and then make sure that I'm not breaking any rules, like giving too much voltage to my chip, or potentially burning out my expensive little servo. That is so sad when that happens. So basically I have my power source here. This is 2 lithium-ion batteries at about 3.5 volts. And I have this case that you can get on Amazon. It's very basic. So they have them oriented so it's positive, positive, negative, negative. It doesn't matter which way you flip it. You just got to remember which way you're doing your wiring. I'm going to eventually wire this positive on the underside to this negative. So I'm connecting it in series. And what that does is it adds the voltage. So if you go, you know, you have negative here, positive here, and you connect that positive to this negative here. So you have a positive going out here and a negative going out here. Basically, you're going to have 7 volts. And you can see that in here. This is my voltage divider. I had some extras left over, and I'm going to have almost 7 volts. It depends on what else is going on. The voltage will drop depending on how much stuff is turned on and being used. So I have 7 volts going from here to my board here, and then that's going down here and snaking up into my servo. Servos, if they don't have enough juice, they're really slow. And I have my joystick here. You can see how fast that is. Pretty cool. Just got to be a little careful with these servos. It's hard to get really precise movements. It's really hard. I'm not good at the math or whatever. Just in general, these are harder to work with because they're cheaper. And you just got to be careful when you have so much power going to this that you don't crack the gear. I've done that, and it ended up pulling a bunch of current, and it ruined the servo and the chip. So I always check to see if anything's hot, and everything looks pretty good. So that's where this raw power is going. It's going to the servo. After that, I have the same power going into the voltage regulator. All this thing does, it's the same as my voltage booster on my pet robot version 2. There's a screw on here, right here, and you just screw that and it reduces the voltage. That's it. Pretty simple. And it's very useful. So I can have 7 volts going here, and then I have that same power source running in through here. I put it down to 4.5 volts about. It depends. And then I'm going to end up hot gluing that screw so it doesn't get bumped around and changed, because I don't want more than 5 volts coming into this chip. I found out through trial and error, after 5 volts, it tends to have problems and gets hot and gets fried. It's too much. I thought these chips could handle more, but that's actually the Arduinos that I think they have stuff on the board that can handle higher voltages. So keep that in mind. Around 4.8 volts max for this kind of chip. And I also have this 5 volt maximum, this about 4.5 to 4.8 volts coming in on this rail. So it's going to my chip, and I also have a capacitor on here. It's a 104 ceramic capacitor. All that does is it fills up with the electricity and then it dumps it out. It just makes sure that there's no brownouts. Remember, a brownout, if you looked at my previous videos, you'll notice a brownout is when the electricity isn't supplied enough in time. So then, you know, the voltage dips enough for the chip to reset or whatnot. It's just good practice. You should put it on every project, really. So that's that. And then I have this 5 volts, this 4.5 volts or whatever, also going to this potentiometer, which I'll show you. These are going to be the 2 LEDs coming out of the eye sockets. And you'll see I can adjust their voltage. Very simple. This is not connected to the chip. Only this is connected to the ADC. And this is connected to, you saw this in a previous video, and this is connected to the raw voltage, about 7 volts here. So let me see if I can show you the proof that I'm getting the voltages that I want. This is a multimeter, and you definitely need one, especially if you're going the route that I'm going. I'm going without the training wheels on. All right, we are balls to the wall, bare bones. This is the big boy stuff, I think. I mean, Arduino and Raspberry Pi are cool, but that stuff holds your hand a lot. This is stuff that normally people go to school for, and I didn't. So, you know, learn the hard way. So you'll see, this thing's great, by the way. This thing has so many functions. You can detect AC voltage in a wall socket. It has a little, I think, a coil in here that can detect it, and it'll warn you of it. It has a backlight. Looks great, right? And it has a stand on the back. I'll put a link in the description. Everybody, you know, they recommend their multimeters. And then these, you can slide them in here. These are kind of pointy. They come with caps that you can put on. It also has a temperature sensor, but, you know, I'm not a multimeter guy. I'm not even... Anyway, I'm just a dude, but I'm having fun. So, if I stick these on this rail, you'll see I'm getting, you know, it says 4 point whatever volts. Let me boost it up. All right, so that's all the way high. I hope it doesn't fry the LEDs. I don't have any resistors going to them. All right, so you see there's a drop in voltage. So just keep in mind, as you're using voltage, it's going to drop. So let's put that down. And now, to prove that I'm getting much more voltage coming straight out of here to my servo, I'm going to tap into these rails. These are great. You know, they have these little pointy needle things that you can stick directly into a breadboard. Makes it very easy. There you go. See that? 6.9 volts. Oh, it's really tricky to get in there. If it's not working on your breadboard, all you got to do is like push the back end. See, it just flashed it. There we go, 6.9. And that's that. So I definitely recommend getting a multimeter. This was maybe $35, $40. Well worth the price. It looks great. I just love it. It's great. I only use it for, you know, just fairly large voltages. I haven't had to use any of the other features yet, but I have a feeling temperature is going to come into play sometime later when I'm playing with temperature sensors and whatnot. So definitely think about getting one of these. There's cheaper ones out there, but I just like this one. It looks cool and it looks pretty solid. So, and it automatically turns off. So all of this is going to go onto this board that I've soldered. So it's already soldered. My solder job, not too bad. I did this a while ago and I just never got around to getting this finalized, but it's happening. So I've also installed a switch on the the back here with just some glue, and I have a series coming up that you all might like, because it's really confusing getting into this stuff in the beginning, and it's a mess. Like, the entire thing is a mess. There's so much information. There's so many different things you can do. It's a mess. So hopefully I'm going to be updating my site with some tutorials. I don't want to give out too much information yet. And so you can see my servo on the back here. I have it. I just had a wire and I just put it around that screw. And then I have this pin that I have it on glue and sticky tape, and then I looped it like that. You know, I just bent it. So that is the mechanism for the jaw. I had some rubber bands. I changed them for springs. Also got a spring pack. Yeah, he's looking good. So he works. I've tested him out. I just haven't finished it yet. So this is all going to be soldered up. It's going to be finalized onto this board, and it is going to go inside of this dude. Stay grounded.